Hello, this is Miss Tidings, and welcome to your last week of instruction. So there's only two more lessons for the year, which is awesome. So we're going to talk about more bivariate data this week, and we're talking about scatter plots, correlation, and then linear regression. So today's focus is going to be on scatter plots and correlation. Some of it might seem familiar to you because you might have done it in 8th grade or middle school, and then some of it might be brand new to you. So the first thing we're going to talk about is a scatter plot. So a scatter plot is a way to display numerical data with two variables, hence bivariate. So you talked about that last week with Mrs. Reese and talking about those two-way tables. So now we're going to be looking at it in a little bit different way. So if a relationship exists between the two sets of data, we say that a correlation exists. Now, I want to kind of bring that to an example. So if there's high correlation, that means when the two sets of data are strongly linked together. So an example that I like to use is think about the temperature right now. And, this week it's been really hot. And so as the temperature increases, I always like to say ice cream sales will probably, as you'd consider it, increase as well, right? So as the temperature increases, the ice cream sales are going to increase. And that's an example of high correlation. So the word correlation is made of co, meaning together, and relation. So there's examples of positive correlation, which is what we just talked about. So a positive correlation, so this is an example of a scatter plot. And imagine we have this, what we call line of best fit, that accurately shows the relationship between the two sets of data. So as your X values increase, your Y values increase as well. So likewise, negative correlation. So envision we have a line of best fit going through there. As your X values increase, now your Y values are actually decreasing. So that's that negative relationship. And if you look at this last scatter plot over here, really you can see that there's no correlation between them. So there's no correlation here, and there's no really line of best fit that accurately describes what's going on. Okay, so as we continue, we want to get more into how can we tell if something has correlation. We can see that just by looking at it, but what we really want to do is say, is there something that could tell us how strong that correlation is? And there's something called our correlation coefficient that's going to help us do that. Okay, so the correlation coefficient is a number, and that number goes between -1 and 1. So we're always going to be between -1 and 1. And if you look at this scale, this is going to help us to determine what's going on. So something that has a perfect positive correlation, look at those lines. It looks like it's making an exact straight line, meaning this would be a strong, perfect positive correlation. Notice that the slope, right? So if you look at the line of best fit, the line of best fit would have had a positive slope, meaning the correlation coefficient is also positive. So if you look down the scale, if we look at this high positive correlation, notice that it's pretty close and accurate to making a straight line, but it's not an exact straight line, which is why 0.8, 0.9, 0.95, these are all strong positive correlations, meaning it's really close to being perfect, but it's not quite perfect. Okay, so as you move on down the scale, and if you look at this picture right here, this helps you to see the strength of that correlation. As we move on down towards the scale, we get to kind of weak positive correlation. So it does have a positive trend to it, but it's not perfect. And then we get to this right here. This would mean that there's no correlation. The scatter plots are just all over the place. So we'd say that there's no correlation between the two. As we progress on down, notice that it goes back up. The positive and negative, so notice that these are all positive and these are all negative. Those tell us about, is it a positive type trend or is it a negative type trend? So the sign tells us is it positive or negative, and then the number itself, the closer it is to 1 or -1, the stronger it is. So down here, this is also strong. It just would be strong negative. And then over on that left-hand side, that was strong positive. Okay, so those are really the type of things that we need to understand when it comes to a correlation coefficient. It's just telling us how close is your scatter plot to making a line. So the value shows how good the correlation is, not how steep the line is, and if it's positive or negative. So to clarify, R is not the slope. Our R value tells us how good of a fit it is. How accurate is that relationship? Okay, so just to clarify, that R value find is not the slope. Okay, so as we continue, now we're going to start looking into some examples. So we're going to use the scatter plot below and answer the questions that follow. So let's take a look first at this scatter plot. Notice that the X values, right, are age in years, and the Y value is the number of cell phone calls. Okay, so what we want to do is we want to figure out first, how did we get this scatter plot? So if we take a look at this table down below, I kind of want to look at this first point right here. So we have age 20, number of phone calls 15. So if we look at this piece, the scatter plot, I'm going to find 20 and I'm going to find 15. So just to clarify, the table correlates to XY points. So in the table, the 2015 correlates to a coordinate point, an XY point. So which is why we get this point 20 and this point 15. So that would be the same for all of these points in this table. So if you look, all these points are the same points that fall on this scatter plot. So let's describe the relationship between the number of cell phone calls and age. So let's think about this. Would this have a positive correlation or would it have a negative correlation? So if we take a look as the X values increase, so as we move from left to right, are those Y values increasing or decreasing? And as you can see, those Y values overall are decreasing. So this would be a negative correlation. So there is a negative correlation between our age and our number of cell phone calls. Now, it's a negative correlation, but we want to know, would we consider this strong or would we consider this weak? And to do that, we're going to try to estimate a line of best fit. So how do we estimate a line of best fit? So it's kind of like a three-step process. So whenever we draw a line of best fit, the first thing that we have to remember is we will always use a straight edge, okay? So we always want to use a straight edge to do so. So a ruler, side of your paper. Second thing we need to know is that we want really an equal number of points, or we'll just say dots. So equal number of dots on each side of the line. And the third thing that we just want to remember is it does not need to go through any point or dot. Okay? So it doesn't need to go through any of those points. We're just trying to get an accurate representation. So what I want you to do right now is I want you to pause the video and I want you to see if you can draw your line of best fit. Okay, so hopefully if you take a look at what I just drew, so this is going to be my line of best fit. And you notice we have about 5-ish above and 5-ish below, right? So this is my line of best fit. Notice it's a straight line. Now, we want to describe the relationship. So if you take a look, would you consider this a pretty good representation for the scatter plot, or would it be pretty weak? So in my opinion, this would be on the weaker side. So I would consider this a pretty weak negative correlation, or we can say weak or moderately weak. So it's not very strong, because if you look, there's a lot of spread between those points, so it doesn't make an exact line, or it's not really close to an exact line, but it is still a negative trend. So if we want to go down, it says predict the value of the correlation coefficient and explain what it means. So I would say if you go back to your scale here, we know that it's going to be negative, and we know it's pretty weak, so it's on the weaker side. So you could pick a negative 0.3 or a negative 0.4. So now again, this is a prediction, right? We don't know exactly what it is. You're actually going to find out in the next lesson to find the exact correlation coefficient. But as long as you have the negative and you have that it's on the weaker side, then you're right where you need to be. So what does that mean? It means that as the age increases, then so as the age increases, the number of phone calls decrease is what we expect. And then we'd say that there is a weak or moderate correlation between age and calls. Okay, so we'd say that our, correlation coefficient is like negative 0.3 or negative 0.4. We know as the age increases, the number of phone calls decrease is what we'd expect. And we'd say there's a weak, moderate correlation between the age and the number of phone calls. Okay, so those are the things that we talk about when it comes to correlation. All right, so as we continue, we're going to take a look right here. So the table shows the correlations for the 4 graphs below. We want to match each graph to the correlation coefficients. So the first thing I want you to do is I want you to write on each graph if you think it's positive or negative or no correlation. So the first graph, graph A, we would consider this to be positive. Graph B, we'd expect that this is negative. Graph C, it's on the positive side. And graph D, nothing's really happening, so we'd say it's about none. And then I want you to estimate those lines of best fit. So we know that the graph A is pretty close to making a line. Graph B is not too bad. Graph C is not as close as graph A, and then we know there's nothing really going on with graph D. So what I'd like you to do is I'd like you to pause the video, and I want you to see, can you match up your graph with the R value? Again, these are R values here. So pause that video and match them up. Okay, so hopefully you see, you end up getting C is graph, if you take a look, graph C, we'd say it's about 0.72. It's a pretty good representation, so it's pretty strong. So we'd say it's on the stronger side, but it's not perfect. If you take a look at B, notice it's a negative 0.9, so that's a strong negative correlation. Graph A, again, if we take a look, that is really close, so this is very close to being perfect. And graph D, there's no correlation to that, so that's why we say it's 0, because there's no line of best fit. There is no correlation between the two. Okay, perfect. We have one other example. So if you look at the last example, it says, which graph represents data used in a linear regression that produces a correlation coefficient closest to -1? Meaning we want it to be strong negative. Okay, so we want to know which one of these is closest to being strong and negative. So the first thing I would do is say, let's eliminate any that are positive. So if we take a look, I see that 3 is positive, and I see that 2 is positive. And then I want to look at 1 and 4. Which one of those is closest to a straight line? And hopefully you will see the one closest to a straight line is number 4. Okay, so to wrap it up and just to make sure that you understand, we can make these scatter plots. They're composed of coordinate points. And what we want to do is we want to estimate and we want to be accurate and say, hey, is there a positive correlation? Is there a negative correlation? Or is there no correlation between the two data sets? Because remember, bivariate data means two variables. So just like we talked about with the temperature in the ice cream sales, we would expect that they have a high correlation. So we would expect that we would have a positive, strong correlation between those. Okay, awesome. Thank you for joining, and we will talk to you soon when we talk about linear regression. See you later.